important that the pipe be anchored in this way for two reasons. Lightweight UPVC pipe may float if the trench becomes flooded. Secondly, the line will be tested under pressure. The center only of each pipe length is anchored to prevent movement during the test. However, it is necessary that the couplings be exposed so that they may be inspected. With the operation in full swing, a complete sequence will be as follows. The lead man, with the aid of the foreman and the second fitter, prepare the dresser coupling. The follower ring, the rubber gasket, and finally the 7-inch middle ring are fitted so that they are flush with the end of the pipe and ready to receive the next 20-foot section. The time, 11:25, as the next section of pipe swings into the trench. As the lead man moves to prepare the end of the new pipe section, the two pipe fitters are completing the previous joint using a torque wrench set for 65 foot-pounds, as recommended by Dresser Manufacturing Company. The lead man is now placing the gasket to the new section, and as we have seen previously, it is measured at 3.5 inches from the end of the pipe. Now that the new section is ready, with the coupling in position, the second pair of fitters should have completed the bolting of the previous joint. They are ready to help in sliding the coupling into place. For final adjustments in the level of the pipe to ensure that there is no offset in the coupling, the pipe fitter taps the 2x4 on which the pipe rests. With the next section ready to be lowered to the trench, the cycle is complete. Time, approximately 17 minutes. Once the line is assembled and properly anchored with sand fill, it is pressure tested. Specifications require a pressure test of 180 pounds per square inch, since the pipeline will operate at a constant pressure of 125 pounds per square inch. At this pressure, the thrust at the ends of the pipe will be approximately 15 tons. The pipe is filled with water and sealed. Compressed air is used to build up to the desired pressure. No leaks are detected at the couplings, so the sand fill is spread evenly over the pipe and joints, covering them to a depth of approximately 10 inches. Earth fill will later be bulldozed over the sand to complete the backfill operation. The pipeline must pass under a highway. Although proper selection of fill would protect the pipe from vibration transmitted from heavy traffic on the highway, it was decided in this instance to use a corrugated culvert. The use of lengths of 2x4 as skids to prevent the couplings from jamming in the corrugations simplified the sliding of the lightweight UPVC pipe through the culvert. Since the culvert was 40 feet in length, it was necessary to join 3 lengths, or 60 feet of the UPVC pipe together to work it through to the other end. As usual, the last few inches are the toughest part. This phase of the project is near completion. At a later date, the UPVC pipe will be continued under the railroad and the main highway to the water tower itself. For the present, it will be tied into the existing 14-inch line via a reducer section and 2 22.5-degree bends at either end. These bends are prefabricated from 18-inch diameter UPVC pipe and wrapped in fiberglass for added strength. At the pump house end, the UPVC pipe from the first elbow section is leveled with the existing 14-inch line. When the line has been properly positioned, the first elbow section is embedded in concrete. Anchored in this way, there is no danger of movement when the line is operating under pressure. The second elbow is reinforced by saddles encased in concrete. With the offsets in position and the concrete reinforcements set, the line is joined to the 14-inch cast iron pipe at the water tower end. Similarly, at the pump house, the reducer is in place.